Hello everyone, welcome to the session on analyzing FHIR data using ML and analytical tools. My name is Ranvijay. I'm a senior program manager at Microsoft. I work on enabling data transformation, data de-identification, as well as ML and analytical scenarios for healthcare data. Prior to joining the team, I was a program manager in Azure Machine Learning, and before joining Microsoft, I worked in healthcare industry for several years. So when it comes to analyzing FHIR data, there are so many things that we can talk about. However, this is a short session. We have about 15 minutes. So I've selected two topics that I think will be useful for the audience. First, I'm going to talk about some of the idiosyncrasies and complexities in FHIR data that you should be aware of when you're building analytical solutions with FHIR data. Then we'll talk about some common analytical and solution patterns that we have seen. I'll also give a couple of quick demos of FHIR affordances and tools that you could use to solve these scenarios. And finally, we will have about 5 minutes for Q&A. So one of the first things you notice when you start working with FHIR data is that it's hierarchical in nature. On the other hand, most of your analytical tools and ML algorithms will require that data has to be in flat tabular format. So you will need to flatten the data. Not only is FHIR data hierarchical, it's also heavily nested. For example, look at the identifier node here. First, it is an array to support multiple identifiers, but you can get the value of the identifier easily. It's right under the identifier node. But to figure out what kind of identifier it is, you need to go 2 layers deeper. In this particular example, the code MR, which represents MRN, is inside the coding array, which is inside a type node. That makes flattening a little complicated. When you start thinking about projecting FHIR data in some kind of tabular format, there are a few additional things that you need to remember to handle. I have listed some of them in no particular order. So you have choice types. What that means is, at one particular position, you can have node of type X or type Y. For example, for the effective field, you can have value of either date-time data type or period data type. So your solution should be able to accept values for any of the data types. Then you have modifier extensions. Modifier extensions modify the meaning of the data. For example, this particular extension modifies the medication request resource to tell that this medication should not be given to a patient. The rest of the resource looks exactly like any other medication request resource. So if you ignore these extensions, you would be interpreting a meaning different from what is intended. The next thing is recursion. You'll notice recursion at multiple places in FHIR. One example is a reference data type containing identifier data type and identifier data type containing the reference data type. Here is another simple example. The item node can recurse infinitely in FHIR. So when you are projecting this resource to tabular format, you need to do some special handling for this. Then you have invariants. These are some additional constraints on the nodes. For example, this particular invariant says that if an observation code is same as an observation component code, then the observation value element associated with the code shall not be present. You'd need to handle this case when you query the data. And finally, in my list, we have references. For a node, you can have references of different types. Also, references can be represented in different ways in FHIR data. These could be absolute URLs, relative URLs, contained URLs. These references are important for purpose of joining the data, so you will need to normalize the references before you can join the data across resources. So these are some of the complexities in the FHIR data that you should familiarize yourself with. We will not discuss the solutions in this session because the solution will depend a lot on your use case and what kind of data you're actually having, but it's important to understand these complexities as you start building your analytical solution. Let's move on to talk about a few common analytical patterns we have observed with our customers. The first pattern is self-service analytics patterns, in which customers have questions that can be answered by querying the FHIR server. Things like what is the trend and population profile of COVID-19 hospitalizations, or what is the impact of COVID-19 on outpatient appointments. In theory, you can answer these and many more such questions by writing a set of FHIR queries. However, many of our customers prefer to use Power BI, which can connect directly to Azure API for FHIR using Power BI connector. Let me show you how that works. What I'm showing you is the Power BI desktop, which is a self-service analytical tool. You can connect it to a variety of data sources, and one of the data sources is FHIR. When I click on Connect, it asks for a URL. I can provide the URL of my FHIR server, and I can also provide an optional FHIR query here. When I click Connect, it performs the authentication and shows me the list of FHIR resources. Bear in mind that this is not the list of FHIR resources that you have in your FHIR server, but it is the list of resources as per the FHIR specification. So I can select the resources that I'm interested in. Let me select patient and observation and encounter. And then I can click on transform data and use Power Query to prepare data for analytics. In the interest of time, let me just show you a pre-built Power BI dashboard running against Azure API for FHIR. You can use the standard Power BI widgets to create reports as well as slice and dice the data as needed. Another common analytical pattern we see is what we can call case-based analytics. This is about performing predictive or descriptive analytics on a subset of data with a specific objective in mind. For example, study of MISC in COVID-19 children. For such analytics, you may want to create a cohort of patients and analyze their data over a period of time. You can use a combination of FHIR capabilities in this scenario. The fundamental capabilities in the FHIR specification that enables this scenario are $export and groups. So once you have identified your patients based on some criteria, you can create a group resource with those patients as members. FHIR servers allow you to export a subset of data based on a group. So using a combination of group, $export, and _since parameter, you can periodically export data from the FHIR server for a set of predefined patients. Now, Azure API for FHIR has also added a de-identification feature as part of $export. It works based on a de-identification config file. So if you want, you can also de-identify the data while it's getting exported. In case of Azure API for FHIR, the exported data files are written in ND-JSON format to Azure storage, from where you can use a variety of tools such as Azure Synapse, Azure Machine Learning, or even Azure Databricks to analyze your data. Let me quickly show you the steps involved in this pattern. So the first step is to identify the patients that you want in your cohort. This query will give you a list of patients based on certain observation codes. In the next step, you can use the list of patients to create a FHIR group. Here, I'm providing the list of patients in the body of the request. Once you have the group, you can use the group ID to export the data belonging to the group of patients. You could also use _type parameter here to export only selected resources, and use _since parameter to do incremental export of data. At the end of export, the data is written on Azure storage. I mentioned de-identified export earlier. In order to do de-identified export on Azure API for FHIR, you use anonymization config parameter that points to a configuration file on Azure storage. This works exactly like export, with the difference that your data is de-identified when it is written on Azure storage. Here's a sample comparison between raw and de-identified data. You can see that based on the configuration, dates are shifted, lat long and city fields are removed, and the postal code is generalized. Now that we have data on Azure storage in ND-JSON format, we can use Azure Synapse Studio to analyze the data. What I'm showing you is Synapse dedicated SQL pool, but you have several other options such as Synapse Serverless or Synapse Spark Pool, Azure Machine Learning, etc. The last scenario I want to talk about is a traditional data warehousing scenario in which customers want to combine their FHIR data with data from other sources and also sometimes transform the FHIR data into a dimensional model. This scenario requires building a custom ETL pipeline. To help in the process, Microsoft has released an open source project called FHIR Analytics Pipelines that helps generate an ADF pipeline to transform and move data from FHIR server to Azure storage in a CDM folder. A CDM folder is a self-describing data folder that contains data as well as metadata. Many Microsoft tools can read data directly from CDM folder. The FHIR Analytics Pipelines open source project also has a tool to generate the pipeline to move data from CDM folder to Synapse dedicated pool. You can access this project at the following location. So this was a whirlwind tour of some of the FHIR capabilities as well as uniqueness of the FHIR data and some analytics and solution patterns. To summarize, make use of the FHIR affordances wherever possible. That will simplify your life. Be aware of the idiosyncrasies of the FHIR data and use the right tool for your scenario. I hope this information would be useful to you when you start working on an analytics project with FHIR data. If you're interested in analytics in general, there was another session by my colleague Stephen Borg on 8th of June. In this session, Stephen talked about performing analytics on FHIR data combined with imaging data. You may want to watch the recording if you missed it. Here are some resources that were referenced in this presentation. You will find these resources in the slide deck. And here's my contact details. Please feel free to reach out to me if you want to follow up from this session. Now we can open the Q&A session.
Thank you so much, Ranvijay. Hello, everyone. This is Sadhana Alangar, HL7's Director of Education. Welcome to this presentation on analyzing FHIR data using ML and analytical tools. Ranvijay Kumar is here from Microsoft to answer your questions. So if you want, you can please post your questions in the question and answer box. And I believe he has requested that you can mute your microphone also if you want to ask questions. We have about 10 minutes for the Q&A session. If you have any questions, please post your questions in the question box or unmute your microphones and ask your questions. There is one question posted. Oh, there are two questions. Okay. Do you want me to read it?
Yeah, I think that would be great.
Okay. Are you aware of a data set combining EHR data and data from regulated devices? Example, blood glucose meters, pumps, etc.
Yes. So I think perhaps you're talking about whether we have seen such scenarios where customers are combining data from EHR as well as the devices. Oh, absolutely. So we have from Microsoft, we also have something called IoT connector that enables customers to bring their IoT data to FHIR server. So this connector, not only it handles your connectivity, but it also has a transformation inbuilt, and you can configure that transformation. So what will happen is while your data is coming in, your data will get transformed into FHIR observations and get stored in the FHIR server. And that allows you to basically have a complete 360-degree view of the patient from different sources. Apart from devices, we also have a DICOM cast capability that is there. So if you have data coming from the DICOM server, then you'll be able to get the DICOM imaging steady source in the FHIR server.
Next question. What do you think are the biggest challenges to performing ML on FHIR data?
Well, I mean, there are several, thank you for the question. There are several challenges, but the biggest one I would say is that, FHIR data is hierarchical and very, very nested. I mentioned some of the challenges in the beginning of the talk where I identified 4 or 5, but handling that hierarchy, that is one. The second thing is that especially if you have data coming from multiple sources, then there will be variety in richness of the data, the quality of the data, and also possibly if you have not normalized your identifiers and terminologies, and then those could be different. So as Graham said yesterday, I mean, it was a very nice quote from him in one of the pub talks. And he mentioned that, your tabular data is clean data, but the FHIR data, not necessarily it's a clean data. Because you might be getting, you have the context, you have history, you have hierarchy, your data coming from multiple sources. So in the most generic scenario, you will need some kind of an ETL pipeline to take your data from FHIR server to your data warehouse, where you can actually do your analytics.
Thank you. Security tags and/or consent rules respected in the analytics pipeline?
So it's a great question. So it's not respected by default, but these are something that you can extract in the analytics pipeline. So the analytics pipeline that the link that I shared, please feel free to use that as an open source project. And it's very configurable in the sense that it allows you to specify what fields, first of all, what resources you are interested in, then what fields you are interested in. And then it extracts those fields and transform your FHIR data and puts it in Azure storage. So you should be able to extract even the tags there. And then based on that, you can filter your data to the downstream systems. But if your question is related to whether we automatically filter the data out while doing the export, the answer is no.
Next question. Can the FHIR Analytics pipeline be configured to separate training, test, validation data sets for ML?
So it's slightly overloaded question, and when I'm thinking about it, you could use it to do that. And perhaps the way that you do it, so the FHIR Analytics pipeline, it's built on top of FHIR export capability. So it internally uses FHIR export. So if you want to build training, validation, and test data for FHIR, you could have different type of filters created at the time of export. However, that may not be the ideal solution for you. I think the better solution would be that take your data into a blob store like the data lake using analytics pipeline, and that will basically convert your data, put it in a tabular format, and then use your whatever tools that you're using, Databricks or Azure ML, to basically split the data into training, validation, and test. And that's also important because when you're building machine learning models, at that time you may want to have different splits, or you may want to experiment with different types of splits between training, test, and validation. So, but if you, so it's better to push that activity as late in the pipeline as possible rather than doing it early in the pipeline, because then you lose the flexibility.
Thank you. I think you answered all the questions. Any more questions? Okay, there's one more. Are you aware of FHIR-specific data quality assessment tools?
So I think the FHIR Validator is a great tool, and we use that. So if you have not used it, I will definitely recommend that. It's open source tool written in Java. If you search for FHIR Validator on internet, you will find it. And that does a pretty good job of detecting issues with the FHIR. Not only that, you can also validate your data against a particular profile. And it gives very detailed, descriptive information about the kind of issues that you have with the data. So we like it a lot.
I think those are all the questions. You answered all the questions. Do you have any closing comments?
No, I mean, thank you for the opportunity. And it's a complex and a very wide field. We are working with several customers, and what we are seeing, as I mentioned in the talk, is there are different scenarios. And depending on your budget, your scenario, and the amount of resources that you have available, you may take a different path here. And we are here to help. So I've shared my contact details. So if you guys want to reach out to us or reach out to me, even after this, feel free to send me a note, and I'll be glad to work with you.
Thank you so much, Ranvijay. Thanks for that excellent session. And thanks everyone for attending this session. Please don't forget to rate this session. This is Sadhana Alangar, HL7's Director of Education, signing off. Bye, everyone. Bye, Ranvijay. Thanks again.
Hey, thank you. Have a good day.
Bye-bye.
Bye.